How much time are you spending just moving data around just to get it into one place so you can finally search it, query it, or analyze it? That's wasted time. And today, we're going to fix that. Welcome to From Silos to Insights, a mini-series of videos that will show you how to unify your data investigation and eliminate the friction of needing to move data around in traditional data management. Before we jump into the workflow, it's helpful to step back and look at the bigger picture. Federated Search is not just a single feature or another connector. It supports a wide range of use cases, from threat hunting and investigations to compliance and historical analysis across data sources like Splunk S3, Security Lake, Machine Data Lake, Azure Data Lakes, Snowflake, DDSS, and more. The bigger idea is simple. Federation gives customers a consistent way to work with the right data in the right place for the right job without constantly moving it around. No matter where your data lives, it's important not to think of this as an either-or decision. Instead, think of it in terms of which approach tends to play the primary role for a given customer or use case. On the left are environments where Machine Data Lake is often the center of gravity, usually because customers want a turnkey, Splunk-managed approach, less custom lake engineering, and a strong AI-ready machine data foundation. On the right are environments where Federated Search tends to play as a larger strategic role, for example, when data needs to stay in place because of residency requirements, shared lake usage, distributed ownership, or the cost of moving large volumes of data. And for the most critical real-time monitoring use cases, the Splunk Index remains the highest performance tier. These decisions can be made at the strategy level or tuned for specific data sources and the source type. Federated Search is positioned as the connective layer across a distributed data ecosystem, helping customers work across data lakes, schemas, teams, and tools without treating Federation as just a point search feature. The key idea is that Federation should support real workloads like investigation, threat hunting, compliance, and historical analysis, and to be used where it makes sense from a cost and performance perspective. Now that we've covered the big picture, let's shift into the specific focus of this video. For this video, we'll use Ingest Processor to route data to our S3 bucket. We'll also let Splunk infer a schema to write to and read from that S3 bucket. Because we're both writing data to S3 and searching it using a Splunk inferred table, this is part of the Unified Dataset Experience, or UDX. We'll also review the setup and configuration so you can reproduce this yourself. What you're looking at here is a modern approach to handling firewall and network data without the traditional overhead. On the left, we start with the firewall, continuously generating syslog data. That data is sent to a Splunk collector for syslog, or SC4S, which standardizes and forwards the events. From there, the data moves into the Splunk Cloud Ingest Processor, where routing decisions are made in real time. Instead of indexing everything, we can intelligently send that data directly to Amazon S3. Now notice this path. It's completely unidirectional, from the firewall to the collector to ingest and into S3. This is important because it allows organizations to store full fidelity data at scale without the cost of indexing everything up front. Now on the right side, this is where the value comes in. Splunk Cloud Search and Reporting can access that data directly in S3. There's no need to move it, no need to duplicate it. Queries are sent to the data and only the results come back. So what you're really seeing here is a separation between where data lives and how it's used. You decide where the data resides, and Splunk makes that data usable without moving it. I'm setting up an Amazon S3 Federated Search workflow using Ingest Processor and SQS notifications. From the S3 dashboard, I create a bucket, give it a name, and create a folder within it. I leave the default encryption settings. Next, I log into Splunk Cloud and open the Data Management app. I go to Connections and select Create Connection. On the first screen, I choose Amazon S3 as the data store. Then I enter the connection details, including a name, optional description, AWS account ID, and the region that matches my Splunk deployment. On the Abilities screen, I select both Run Federated Search and Send Data from Ingest Processor. This combination is important because it allows a single connection to both route data into S3 and search that data later. For authentication, I choose IAM role authentication. Splunk provides a custom trust policy. I copy that policy and switch over to AWS. In AWS, I open the IAM console, go to Roles, and update my existing role. I replace or update the trust relationship using the policy from Splunk, then add the required tag, Splunk Assumable Role set to True. I also copy the role ARN. Back in Splunk, I paste the role ARN into the connection. Since I'm not using an Iceberg REST catalog, I skip catalog configuration and create the connection. At this point, the connection exists, but dataset permissions will be finalized later. Next, I go to Datasets and select Create Dataset. I choose Amazon S3 and select the existing connection. Then I define the dataset by providing a name, optional description, and the S3 location. The path must point to a folder, not a single file. For provenance, I select Unified, which supports both data routing and federated search. On the configuration screen, I choose the data format, compression, and schema. I also enable federated search, which requires an SQS-Q-ARN. Now I move to AWS and create an SQS queue. I choose a standard queue, give it a name, and disable in-transit encryption. Then I update the queue policy to allow Amazon S3 to send messages using send message, scoped to my specific S3 bucket. This policy must reference both the SQSQ ARN and the S3 bucket ARN. Once complete, I copy the queue ARN. Next, I update the Splunk IAM role permissions to allow sending and receiving messages. Then I configure S3 event notifications. I open the bucket, go to Properties, and create a new event notification. I define a name and carefully set a prefix so it applies only to the dataset folder. For event types, I select Object Create, Object Removal, and Restore Events. I set the destination to SQS and paste in the queue ARN. If AWS returns a validation error, I verify the queue policy and ARNs. Once complete, I return to Splunk and continue dataset creation. If the bucket uses KMS encryption, I add the KMS key ARN. Splunk then generates a resource access policy, which grants the role access to S3, SQS, and KMS, if applicable. After confirming the policy, I complete the dataset creation. Now the dataset is ready. Next, I configure the ingest processor. In data management settings, I create a new pipeline. For this demo, I use the ASA template and set the destination to the S3 dataset. Then I apply the pipeline. Once active, data begins flowing into S3. At this point, the full workflow is complete. Data lands in S3, S3 sends notifications to SQS, and Splunk can query the data using federated search. We can validate this by checking the ingest pipeline metrics, confirming data in the S3 bucket, and running searches against the dataset. As new data arrives, it becomes immediately searchable without any additional steps. Now that we've walked through the setup, here's what it really represents. Data flows once into S3 and stays where it lives. There's no local ingestion, no schema management, no glue tables to maintain. From there, Splunk simply queries the data in place. That means simpler operations, lower overhead, and stronger compliance since the data never has to move. You decide where the data resides, and Splunk makes it usable. We can enhance our search to extract meaningful insights such as timestamps, source and destination IPs, ports, applications, interfaces, and traffic direction. Now that we have access to the data and it's in a usable format, let's start with a simple example. We're going to look at a local lookup. This lookup contains a list of known bad IP addresses, along with associated threat names and severity levels. Think of this as contextual intelligence. It allows us to take raw data and quickly identify activity that may already be known to be malicious. From here, we can use this lookup to enrich our searches and surface meaningful insights much faster. Now that we've introduced the lookup, let's apply it to our S3 data. We take the data coming directly from S3 and compare it against our list of known bad addresses. From there, we identify any matching IPs and enrich those results with additional context. That includes the threat name, the severity, and how often those addresses appear in the data. So instead of just raw events, we now have prioritized meaningful insights. We're not just seeing activity, we're understanding the risk and the impact in real time. And finally, we add a stats command so we can take those results and turn them into a dashboard. As we wrap up, the value of federated search is about giving organizations more flexibility in how they work with data. Not every dataset needs to be fully ingested before it becomes useful. Some data may live in Amazon S3, cloud data lakes, partner environments, archival storage, or other external repositories. With federated search, Splunk lets teams search that data where it already lives, using the familiar search experience analysts already know. That means security, IT, and operations teams can investigate faster, expand visibility, and reduce the friction of moving data just to ask a question. Instead of waiting for onboarding, indexing, or duplication, teams can query external datasets directly and bring the results into the investigation when needed. This creates a smarter operating model. High-value, frequently used data can still be indexed locally for performance and real-time alerting, while historical, compliance, or enrichment data can remain external and searchable through federation. Federated search helps organizations shift from a data movement strategy to a data access strategy. The real value is simple. Keep data where it makes sense, search it when it matters, and bring insights back into Splunk where teams can act. My name is Mark Snyder, and thank you for watching.